And the fourth approach is the fully featured build system. For example, consider we want to take some build system like scones and so on and use it to build a compiler driver on top of it. This approach works, but this is the overkill for this solution is pretty big. So all these solutions in general work, but they're not suitable because either they are ugly or have some external dependencies, and so all this has some problems. But from this we can at least grab some ideas. So what are the requirements for the compiler driver? First of all, compiler driver should be easy configurable. So it should provide some language so we can define all different ways how the set of input files is transformed via different tools into set of output files, and how all different options are handled, and so on. Also, we don't want extra dependencies. So no Perl, no Python, no extra scripting languages. So we shouldn't enforce the user to install some third-party software to run compiler. Also, it can be good if the compiler driver will be reconfigurable at the runtime. So we can just add some different compilation paths on fly. Also, it should be flexible and universal. We should be able to deal with all different crazy tools and all those options. For example, the current compiler driver was modeled to be a substitution for the GCC. So we need to deal with all different options and all different knobs. And there are also many other requirements in general. So what we propose. The compiler driver, the overall design of the compiler driver was partially inspired by the scones toolkit. So it has same notions of tools, actions, and so on. We already have some description language in the LLVM. It's called TableGen. So we decided to use the TableGen language to describe the compiler driver because we already have parser for this language, and thus we just implemented a TableGen backend which converts the description of the compiler driver into set of C++ files. It's pretty natural to describe the logic of the compiler driver as a graph, and because we already have some chains of the compilation. Also, compiler driver selects the best compilation way automatically. For example, there can be several possibilities to compile a same set of inputs into outputs. And thus we can, for example, select the path which contains lower amount of tool invocations. And surely the compiler driver is driven by the set of input files and command line arguments. What is a graph-based approach which I talked about? So, tools which are used into the compilation forms nodes in the transformation graph. So we call this compilation graph. And edges in this graph they define possible transformation paths. These edges are weighted, so weight depends on command line of set of input languages and so on. It's some internal actually thing to the compiler driver because the compilation path with maximal weight is used. I won't say much about this, so if anybody interested in exactly what weight is and how it's calculated, you can consult the documentation. This is a high-level overview of the compiler driver itself. First of all, we have a set of configuration libraries which are used to populate the compilation graph. So they define configuration libraries actually define the different ways how the set of input files are compiled. So from this set, the compilation graph is built. Then from the compilation graph, set of possible supported options is extracted. And this set of options is used to pass command line arguments. Yeah? And also the set of input files, set of options, which are driven by the command line arguments, and compilation graph itself forms the set of actions which are needed to compile the set of input files into set of output files. So This is the high-level overview how the current compiler driver is working. Let's proceed to the low-level details. So actually, I will try to describe the how one should write the compiler driver descriptions and build their own compiler driver. First of all, as everything is driven by options, we try to summarize all different flavors of different command line options used by the GCC. First type of options are pretty easy. It's just a switch option which acts like a Boolean variable. And another possibility is parameter option, so it has some, well, name and value. The extension for the parameter option is just when the name is same, but the value can be just list of possible values. Another thing is prefix options, so you don't have this assignment explicitly. Rather, you have some prefix and the arguments. They can be some delimiter, they can be blank delimiter, and so on. The extension of this is prefix option list, so you have the same prefix but different values. And also we include some options aliases, so you can, for example, wire one option into another. So it can be used to build a set of shorter options. Yeah. How one should define the set of options? It's pretty easy. So here we define the we define the three options. We define the action, which is used how to forward this option to the tool. And also we define the help string for this option. Currently we have two possible variants. In this example we have two possible variants of actions. So this action of forward is pretty simple. We just need to forward this option as is to the tool. Another variant is the unpack values. So it's used to forward this form of options to the tool. So compiler driver will just forward the value of this option to the tool. So, and in this example, those three description of options will make the following support. So we can build some sort of linker, for example. Next